All right, so we're going to go to our ebook here, and today we're looking at 1.2.5. So I'm going to go over to the left side of my screen and click on Chapter 1, and then when it drops down, I'm going to go to 2.5. So in this section, we're looking at representing fractions as decimals and percentages. So as you see over here, it has representations of a portion, and here you'd write the fraction up top. So for example, it was 2/5, and you write 2/5 up top, and then you write 2/5 as a decimal, so 2 divided by 5, which would give you 0.4, and then you multiply it by 100 to get to your percent. All right, so that's how you would write the three different ways of representing a probability. All right, so it says when probabilities and portions are expressed as fractions, they can sometimes be difficult to compare. For example, is 2/5 probability of winning a game greater than 3/7 probability? So far we've used different ways to represent a portion to help figure out whether 0.9 repeating is equal to 1. And so in this lesson, we're going to develop strategies to rewrite fractions so you can compare different portions. All right, let's top one here. It says Leila wants to rewrite 10 over 25 as a percent. She decided to represent 10 over 25 first in a picture. For an animation, watch this video here. And so you could click on this video, it's about a minute long, and it shows you visually how if you have 10 25ths, so here it's divided into 25ths, and if 10 of them are shaded, like we see right there, and then we took this grid of 10 by 10, 100, and shaded 10 of the 25, 10 of the 25, 10 of the 25, and 10 of the 25, we can count how many total are shaded. And here we see that 40 out of 100 would be shaded, okay? So if you take this picture and you put it 4 times here in the grid of 10 by 10, then you're going to get 40 out of 100. So it says, how many sets of 25 will she need to make 100? In other words, what do you have to multiply 25 by to get to 100? And it shows you right here, you need to multiply it by 4. And so what you multiply the denominator by, you have to multiply the numerator by. So that way you can keep the fractions equivalent. But remember, why are we putting this over 100? Think about what percent means. Per cent. How many cents are in a dollar? We need it to be over 100. And as we move down to 196, it shows the method for putting something over 100. In this case, we're multiplying by 4 over 4. Now notice this fraction here is just going to be equivalent to 1. So you're just taking a fraction, in this case 10 over 25, and multiplying it by a fraction that's equivalent to 1 that will get you to a fraction where the denominator is 100. All right? Same thing here we're going to do on B. 9 over 25 multiplied by 6 over 6. All right? Multiplying by 3 over 3. Your fraction that you're multiplying by, if it's the same number on the top as the bottom, it's going to be equivalent to 1, and therefore you're going to end up with an equivalent fraction. And now here, you're going to actually fill in what you would have to multiply 5 by to get to 40, and then multiply 7 by that same number to get to your denominator. And here you multiply 7 by what to get to 70, and then multiply 5 by that same number to get to your numerator. Just remember the fraction has to be equivalent to 1. Here, this is a little bit of freedom. You get to make 3 new fractions that are equivalent. So it doesn't matter what those fractions are. You can multiply 7 by whatever, and then multiply 12 by that same number. Multiply 3 by whatever, multiply 10 by that same number. As long as you're multiplying numerator and denominator by the same numbers, you will get an equivalent fraction. And then here, you're going to be comparing fractions. So this is why we need to make them equivalent, because times they're going to have different denominators like 8, 16, and 24. And so now I need to figure out, okay, how can I compare these? In other words, how can I make them all a fraction with the same denominator? All right, so you're going to have to find the 8, 16, and 24, and then you're going to have to multiply these numerators by whatever number it takes, to multiply from, say, 16 to get to whatever your new denominator is. And then again, we're trying to get it so 100 is our bottom denominator here. So what do you have to multiply 4 by to get to 100? Multiply the top by the same number. What do you have to multiply 200 by to get to 100? It's kind of tricky here. Same with 16. You might not end up with such a clear whole number. It might be a fraction. All right. And then here you're comparing the different types of probability, but notice some of them are as fractions, some of them are as percentages, and that's why it's so important for us to be able to go from fraction to decimal to percent. Your learning log, just think about these. You don't actually have to log them anywhere, okay? But you're just going to be thinking about this question, see if it makes sense to you, and then you're going to move on to the math notes. All right, here it's talking about the multiplicative identity, and it gives you the definition for it right here, and it's just saying taking a number, multiplying it by 1 will give you that number. And you have the review and preview. Remember, I post homework help for these. All right, good luck. Let me know if you have any questions. Thank you.